Okay, now we're actually going to talk about symmetry, and this was a little bit harder and it's harder to see, but you're going to have to trust me a little bit on this. And I'll tell you right now, I will not ask tons and tons of questions on this on your future test, but you are still going to be expected to know it. When we work with what are called tessellations, we have to be able to figure out the patterns used. And one of those patterns is called translation symmetry. And translation symmetry is when you have something that's repeated over and over again perfectly. Like this one down here below, this has translational symmetry. Notice that kind of bird shape is just reflected over and over again. Yeah, it's different colors, but it's completely reflected. I just translated it to make a new pattern, translate it, new pattern, translate it, new pattern, translate it, new pattern, over and over again with that. So this one has translation symmetry because you can see how it's been used over and over again. Kind of easy, right? Cool? No? Yeah? I think it's pretty cool. Now the next one is called a Thrus pattern. Now a Thrus pattern is when you have translation symmetry along a line, and this you can see the Thrus pattern. It's a fancy name, okay, Thrus pattern. Just realize translational symmetry, you're going to have a Thrus pattern. Yeah, Thrus, seriously, it's F-R-I-E-Z-E. Thrus, or frise, I don't know, I'm not French. Anyone help me here? Oh wait, I'm in a room by myself. I don't have my French speaking students, not good. Alright, so when you work with it, now, if it has symmetry that continues along the line, we have this Thrus pattern. Now notice here, it says both of the Thrus patterns shown below have translation symmetry. The pattern on the right has the glide reflection symmetry. Now what's that? Glide reflection symmetry is when I actually reflect and then glide. Do you see this pattern repeating right here? Notice it repeats right here. But if I was to translate this one, you notice that you get the same thing. It literally would reflect over. And so that is called a glide reflection symmetry. Aren't you so excited? So this would be a glide reflection symmetry. And what I'm doing, understand, is notice it's reflected and then one part of the pattern is kind of glided a little bit more. But notice this pattern repeats itself perfectly as we slide along. So could I also call this translation symmetry? Yeah. So good. So one thing it's supposed to do, and I forgot to write it down, is I wrote it down here, is that you have a glide reflection symmetry if you reflect after a glide and reflecting. So it's kind of like you do translation twice. I reflected over and then I glided one of them, and I just continue to do so. So here's some of our identification stuff when you work with it. What is being repeated here? Over and over, this note, over and over and over again. So that would be considered a translation symmetry because I just translated the same thing over and over again to get that same pattern. Now on this next one, it's also a translation symmetry. Notice to get a glide reflection, you're going to be translation symmetry. So we have translation symmetry. And I just keep continuing over. But notice, if I could reflect this, I have a line that would be here. I could have reflected over. And you could see that it reflected onto itself. And so I reflected, and then I kept gliding these before. And so with this one, I have a glide reflection symmetry. So that's the glide reflection symmetry. And yes, I know my handwriting's bad, so please forgive me on that. So glide reflection symmetry. Let's keep on going. Now, how about, now it says identify the symmetry in each Thrus pattern. Basically, that's translation symmetry, or it's going to be in glide reflection. On this one, do you see any perfect reflections with these? If you notice, there's no perfect ones with this. So this one's just a translation symmetry. And it's very hard to see this, so please just kind of bear with me. That's hard to see. Now on the next one, can you see the perfect reflection over? Okay, so this one's easier to see. I can literally reflect it. So I know I'm going to end up what's called a glide reflection symmetry because I can reflect my pattern over and I can still keep gliding it. which also means then it's still considered translation symmetry. You cannot have glide reflection without translation symmetry. So you have to have both. All right, now we got one other term which I absolutely love, okay? And that is a tessellation. Now, tessellation really is just another word for a tiling. A tessellation is a repeating pattern that completely covers a plane with no gaps or overlaps. The measures of the angles that meet at each vertex must add up to, as you can see, 360 degrees. Look around this room. You have the cinder blocks, okay? This, the concrete blocks. Notice they all meet at a point. It's beautiful at right angles, but all the way around it's going to be what? 360 degrees. Look at the tile patterns, even complicated ones on the floor or in subways or on tiling. They all match up. They all go around there. So we want to make sure they always go up to 360. Now, how do I find one interior angle? If I had that and it was a regular one, remember we did this with regular polygons, we'd go N, we're not going to worry about that. I'm not going to go there right now. Sorry, I was going to get more complicated than I needed to be. All right, now look at the one below. It says, in the tessellation shown, each angle of the quadrilateral occurs once at each vertex because the angle measures of any quadrilateral add up to 360. Any quadrilateral can be used to tessellate the plane. 4 copies of the quadrilateral meet each vertex. So totally I'm going to make sure how this goes. You notice the 4 different shades there. Easy to show a tessellation here. How about this triangle? This triangle can easily make it a tessellation too, because we know the 3 angles of a triangle add up to 180. So I know I can get the 180 here. Well, that means I can literally put the 3 angles in another order, and I'm still going to be able to get the fact that we have a tessellation. Now, here's the thing. We have 2 different types of tessellations. We're going to have what's called a regular tessellation. Now, guys, a regular polygon, all the sides and all the angles are the same. Now, notice what it says. A regular tessellation is formed by congruent regular polygons. Very simple to get. Then we have what's called a semi-irregular. Semi-irregular tessellation. It's formed by 2 or more different regular polygons. Regular tessellation, here's with the equilateral triangles, right? This one uses equilateral triangles. All right, and squares. There should be triangles and squares. If I use more than one regular polygon, it becomes semi-regular tessellation. Now, we also can have neither. You can still have tessellations that are really, really, really cool, but they're neither. They're just not met by regular polygons. So let's identify this one. On this first one, do I have a regular polygon? In the instant you say no, you realize, yes, that's a tessellation, but that's neither. Now on this next one, it's all made up of equilateral triangles. So this one is a regular tessellation. Notice this one's made of hexagon, triangle, and a square. So I have 3 different regular ones, so this would be considered semi-regular. I would expect you to be able to probably identify the different types of tessellations even before the freeze patterns of working with these. Alright, I hope this helps you on your homework. And I know this is kind of confusing, but you guys, you can feel free after hanging out with your mom on Mother's Day, you can give me a call or come into school at 7:30 in the morning on Monday. I'll be more than glad to help you with this and clarify.